Hello guys, today we are going to talk about conversions, and here we've got two topics, casting and parsing. Let's go to the first one. Casting, what is it exactly? It's a simple process of converting a variable into another type, which are in some way compatible. Okay, what's more, we've got two types of casting. Implicit, which is automatically converted by a compiler, and explicit, which we have to provide a specific syntax for that. And a few words about assignment compatibility. It matters because if it occurs, then we can cast our variable implicitly or explicitly, and we can do that only, let's say, for a family of variables, like numbers, for instance. And let's say we can cast integer into a long type or integer into a short or etc., right? If assignment compatibility doesn't occur, then we must use parsing. But about this I tell you later. Okay, let's dive into implicit casting. It's also called a widening conversion. Here we've got a graph with casting directions. And the most important thing here is that we start from smaller type like byte and we want to extend it to bigger one like short, for instance. And this works implicitly. And also we can do the same if we want to extend, for instance, short into long, and we want to, avoid the intermediate type like integer here. And we can do this in the same way, just assigning smaller to longer. That's all. Okay, let's go now to explicit casting, also known as narrowing conversion. And here we want to cast larger type into smaller one. And we achieve this by cast operator. And cast operator is brackets and inside a type on which we want to cast the larger variable. Okay, and that's pretty all, and I show you in example. So let's go to the practice. Okay, I prepared a new project, conversions, and we start here from, let's say, implicit. And here we want to, as you remember, it is automatically, it means implicitly. So we want to, for instance, cast byte variable, let's say b, let's say 10, and we want to cast it into a bigger one like short b. And that's all, it works fine, and we've got casting here, and we can print it out also. Let's say byte b, and here short s. Okay, let's run it. Byte and short, and works fine. Okay, let's try now to cast the byte into long b. Okay, we don't have an error here, so it seems okay. And all here. Let's run it again. We've got 10, of course. Okay, and what's more, and maybe we now want to cast, let's say, our short into the float or double. Let's say double. Oops. Double the and s, let's say. Let's check this out. D here. What's happened here? Okay, please notice that we've got 10.0, right? Because this is a floating point type, as you know. Okay, and this is how exactly work implicit casting. There's nothing more. Please remember for floating and double, there will be also floating point value, of course. Okay, and that's pretty all here. Let's go to explicit. As you already know, for explicit casting, we need to use cast operator. But why do we need this? The answer is quite simple. Please notice in explicit casting, we assign smaller type into bigger one. So we are protected because we don't have any data leaks. Because smaller type will always fit into the larger one, right? But in explicit, we don't have that kind of assurance. So we have to put casting operator to emphasize that we are the programmers and we know what we are doing. And we are aware of data leaks if we are across a type range, of course. So let's see this on examples. Okay, explicit, and let's say we've got int a variable, something like this, and you want to casting the e variable into short type, short s2 because I've got already s, and e. And here we've got the problem because we need to use casting operator, right? Even we've got a hint here, cast expression to short. We can click here, or we can write by ourselves short. So we set the type on which we want to cast, right? And now it's fine. Okay, I try to print it out. Let's say int s2 short 2 and run it. Okay, that's fine. We've got this. Everything's works perfect. Okay, let's try now to cast our integer into byte. Byte b2 and e. Of course, we've got here a byte operator. And okay, it looks okay. Let's try to print it out. And b2. Okay. And as you see, we've got value 76, but the integer 1100. And that's why we crossed the byte range, because as we know, the byte range is from 1 to 0 to 1 to 7, something like this, right? So let's try to change it to 1 to 7, and now it should be okay, right? Let's try one higher number, and now we have the next value, because when it across the range, it start counting from the smaller one, right? So when we try to next one, the next value will be minus 127. As you see. So that's why we need to look carefully on the range. So that's pretty all. It works fine for others in the same way. Okay, let's move on to parsing. What is it exactly? It's a process of converting a variable type into another which are not compatible. This is very important because here we want to convert, let's say, integer into a string or string into integer or other. right? This is very important. And of course, if it's possible, because for instance, we cannot parse, let's say, boolean into double, right? This is prohibited. And we achieve this by two methods. First, parse, and type, it could be integer, double, long, and etc. And value of, this is the second method. Okay, let's go to practice and see how it looks like. Okay, let's parse string into numbers. String numbers, and let's say we've got string s0, and we've got here 1 2 3 number, of course, and we want parse this string into integer. So you've got int e equal, okay, I've got e already here, so maybe I comment this part of code and here. Okay, no, that's okay now. And I want to parse the string into integer. So I use integer wrapper class. This is called class wrapper for integer. For each primitive types there exists a wrapper class. About those class I tell you more, but today we will use only the methods to parsing. Okay, so we write the integer for integers, of course, and then we've got a parse int, and as a parameter we need to provide a string. So s0 here, semicolon, and that's all right. Let's try to print it now. Okay, let's say s0 s0 I. Okay. Okay, as you see, everything's work fine. And what if the string is not valid? Because here we've got a number, of course, but someone can put as a string a sort of another chain, like a name or something like that, like Joker, let's say. And let's try to parse into I1, and here S1, and let's see what happened here. I1, and run it again. Okay, we've got the exception here for input string Joker. And this is not a number, simply. And so we've got the exception. So this is prohibited. Of course, the string must be, you know, kind of number, right? Must be valid. So I remove it, and please remember about this. Okay, what else? Let's try to maybe some other kind of number. Let's say floating point number, like this one, and let's try to parse into double. D double dot parse double. As you see, again we can pass a string for parse double method. S1 here, d S1 S1. Okay, let's run it. Of course, that works fine. Also, we can do the same for our previous number, previous string actually, 1 2 3. Let's try 1 here 0, and here we've got 1 1. And check this out. And of course we've got the double type, but look at here, we've got the dot O here, right? Because this is double type, of course. So this conversion, this parsing actually works perfectly. And remember about exception when the string is not a number, right? So, and this works for each other types, like byte, parse byte, long, and of course float, parse float, right? So everywhere we've got those methods. Okay, and the last part of conversion, numbers into string. This is very simple. Let's say string we've got and 0, let's say, and we want to change an integer into a string. So let's say we've got a string dot value of, and as a parameter we can pass a variable like integer. We can, let's say, here put an integer int 0, let's say something like this, and we can put it here int 0, and that's fine. As you see, I use a value of method from string class, which convert the numbers and other type of into string. Cout int 0 int 0 and 0 and 0. Okay, and let's see, 56, that's okay. And we can do the same for another types, like let's say string num1, string value of for value of for long, for char, for float, double, boolean, and etc. Right? So everything we can parse into string, even char and boolean. Okay, let's try to float maybe. So we've got 33f, of course, and this is our float. What else? Let's say boolean now. True, right? And let's say maybe the last one value as a char. Let's say $. Okay. 1, 2, 3. 1, 2, 3. 3, 2, 1. Okay, and let's see what happened here. Okay, everything works fine. This is the last thing which I wanted to show you.